in this event.
Oh, thank you, Lars. Thank you for the kind introduction. Let me try to share my screen. Is my screen visible? I hope so.
Yes, we can see it. Thanks.
Okay,
yes.
Perfect. So thank you very much. Thank you for the introduction. You've said it all, so I'm not sure what I'm going to present now. I think I have an hour so I think I have like almost 50 slides, but you can interrupt me at any time. I'm not sure if I'm going to see raised hands, so whatever you find necessary to interrupt me, please interrupt me. So
yes, we can keep the questions for the end of the talk, and if we could finish the talk in about 45 minutes, so we have some time for questions, because there is another talk after this one from another cluster, so we don't have a conflict between when we finish and when they begin. Thanks.
Okay, I will do my best. That's perfect. And so I try to split this presentation a bit in what we do, what is GEOGLAM, so an introduction on GEOGLAM, some of our work, and then also some of our partners' work, some of the research that we're currently working on. So let me start with what is GEOGLAM. How can I progress? Okay, good. So
if you could set it to presenter mode, because now we see also the slides to the left of the PowerPoint.
Okay. Should be in presenter mode. Let me check.
Maybe you use two screens or
yeah, I use two screens, so let me check what I'm sharing actually. So what is being shared here? Pause. There. I'm gonna share maybe just my screen. Screen one, no, screen two. Okay. Share. And now, can you now see it full screen?
This is perfect, thanks.
Okay, good. Sorry for that. So GEOGLAM we launched in 2011. We were launched by the Ministry of Agriculture, led by the Minister of France, so in 2011. And why GEOGLAM was launched was because of two big food price spikes, one in 2008 and one 2010, 2011. And as you can see in the chart on the bottom right of the slide, well, there's a continuous rise of food prices for wheat in this case. But I should update the slide because it only goes till 2025. You already saw the start of COVID and Ukraine, which had an impact. But actually, due to the work of some of our colleagues in GEOGLAM, we were able to predict some of the production in Ukraine, where we actually had no field data anymore to stabilize the market. So the objective why we started in 2011 was really to increase market transparency, improve food security by producing and disseminating relevant, timely, and actionable satellite-based information on the agricultural conditions at national, regional, and global scale. So it was really dedicated to market support. In the meanwhile, we have had several other mandates, and this is a representation of GEOGLAM, the thematic structure, giving you some idea of what we do. So on the Bottom right, you have some of our policies. I just picked two, food security and climate, because those are the biggest two. And we have different products for that. I will focus much more on the food security part and less on the climate part. I only have two slides on climate. Most of it is on food security, but of course, those two are very much intertwined. So on the food security part, we have market information. This is really dedicated towards the big producing countries, where we do support the FAO agricultural market information system. We provide on a monthly basis information to them, and they use that information to assess production, and at the end of the day, production figures, and by that way also value of a certain crop. On the early warning part, we do the same thing, but for countries at need. We look at what are the issues, where are the problems, what is the prediction for the ongoing season, will it be good or will it be bad in certain countries. Early warning has less impact at a global scale. The market information, of course, has a big impact on global scale. On climate part, we do mitigation and adaptation. We have a product for national adaptation plan, where we support countries in implementing EO-based analysis to support their national adaptation plans. On mitigations, we work with, for instance, the European Space Agency on global stocktake, but also at national level on NDCs and on the FULU roadmap. These products, they drive our needs. Our needs go into our R&D component, mostly guided by the essential agricultural variables. I'll come back to that later. Then all the things we do is open source. So the data is open. The tools that we use are open. And so based on that, the data and the tools, we come up with information products. We have a big component where we work on in-situ data, because we have good connections with space agencies, NASA, with the ESA, with JAXA, and many more through CEOs. So we have access to most of the open and free EO data. We also have a couple of connections with commercial players, so we get extra data in there. One of the biggest bottlenecks for research and for applications actually in situ data. For that, we work with countries, but also with big research projects. That all is combined into information products. And then those information products, we do a lot of capacity building and co-development with national and international organizations to have these products used in countries, in regions, and at global scale. I can't talk about GEOGLAM without talking about the crop monitor. This is a global view. This is an old image. I'll come to some newer ones, but this gives you an idea of what this global crop monitor actually is. It gives an indication on where the crops are grown, what the big regions are, which crops you see with the symbol, and the colors represent the conditions. You have exceptional, favorable, watch, poor, failure, out of season, and actually no data. So this is just the crops and the situation. If we now go a bit more in detail, so you have crop monitor for AMIS, you have early warning, crop monitor. Of course, as soon as something happens, that gets a lot of attention in press. So we get lots of press coverage. And then if you talk to people from FAO, their senior economists, they really appreciate all the work that we're doing there. Like I said, we have actually 2 products, but 3 different levels. You have the one for AMIS, you have the one for the early warning, and you have the global one. If we go into AMIS, AMIS covers actually large commodities, or the big commodities, wheat, maize, soybean, and rice. So we cover with that 80 to 95% of global production, and we have over 40 people contributing to it. So I need to explain, so these are the countries that we work on for AMI. So these are major producing countries. Just an example of rice production at global scale. You see the situation, but you also see the drivers. Was it too wet? Was it too dry? Was it too hot? Was it too cold? Is there an extreme event, pest and disease? So all that information is gathered. We have to be clear here. The map you see is not a satellite-based map. It's an interpretation of different satellite observations. So the way this works is over 40 organizations come together. They look at their EO data, they look at their yield models, they look at whatever information they have. And every month there is a conference call with those 40 organizations. And based on consensus, this report is, or this figure is created. And you also even get like these pie charts on what are the big producers, what's the situation there, how far are they in the season, how is the season going. And actually that information goes into the AIMS bulletin, where FAO also puts their production estimates, where USDA puts their production estimates to that. Similar, but launched later. So the AMIS was launched in 2013. This one is launched in 2016. We cover different crops: maize, sorghum, millet, wheat, beans, teff, and rice. And there's over 60 contributing organizations in here. Different countries, as you will see on the map there at bottom left. So lots, big focus on Africa, but also on Southeast Asia. An example also here for Southeast Asia: what were the conditions, what were the drivers, and you see some of the people contributing to that. Next to that, we also have a crop monitor exploring tool, where at global scale you can zoom in, you can zoom out. The QR code points you to the website, and you can play with zooming in, zooming out, seeing different countries. You have different crop calendars. You can look at the first maize season, second maize season. You can choose between crops, and you have an idea. But for this, yeah, you need already have some background. So there's 3 products: the PDF version in reports that are sent out to the community, but you can also have a look at the crop monitor exploring tool. Of course, this has an impact. We're not doing this for fun. I'll show you a couple of impacts for crop monitor. This one is from 2017, where we installed crop monitor in Uganda at national scale, and actually it was used to prevent to have an early operation for the disaster that happened there. So normally they reacted to crop failure by having it 3 months earlier. They could proactively mitigate loss and damage, and by that way they saved, according to them, 2.6 million USD, and 150,000 people were actually helped just to know in advance what is currently ongoing and how does the season look for future implementation. The crop monitor is not only national scale, it's also regional scale. So crop monitor, big support here by NASA Harvest, which is a US-based program which contributes quite a lot to GEOGLAM. They did an assessment of the El Nino, what the impact was of El Nino of 24 in Southern Africa. So they looked at the region, they looked at crop calendars, they looked at yield estimations, they looked at rainfall, and they made a consensus-based approach or report on the impact of that very severe drought in Southern Africa. And also based on that, there was a possibility for early action and response from the humanitarian agencies. And so national emergencies were declared in Malawi, Zambia, and Zimbabwe based on that work. Similar, but now more looking at yield anomalies associated with the ENSO. Again, this work is combined with the previous work. So based on yield estimations, yield models behind the crop monitor, we could actually have a view of what the global yield impacts were 6 months before harvest. So that's background on the global one. Regional one as well is a derivative from the crop monitor, where for ICPAC, which is a technical arm for the IGAD region, working much more on climate. They have their own website. Crop monitor information is used in that website just to come up with warnings for different regions in Eastern Africa, which is their mandate. So experts from GEOGLAM support this work to come up with an anomaly hotspot warning system for different areas in East Africa. That was a crop monitor. A similar approach, but less at a global and regional scale, much more adapted to the countries, is national adaptation planning, where we've seen that quite a lot of the countries were using outdated maps, outdated information to come up with their national adaptation plans. So we looked at, together with national experts, what is needed, how can we support, and that was actually, we started working on a document. The document is finished. It's publicly available. It's on how to integrate EO data into national adaptation plans for the agriculture and food security part. Main conclusions actually was that in lots of countries, there's a lack of an institutional framework. If that institutional framework is there, we need to push for the technical framework. And then we need to do capacity building and co-design, co-development. And then, of course, there's always the aspect of financial support, which is in lots of cases the most difficult part, and especially now, given the changing geopolitics. So those were our more operational products, let's say our day-to-day business, our bread and butter. Of course, like I said in the first slide or the second slide, there's a big R&D component to GEOGLAM. And that is based on something we called essential agricultural variables. It's very much linked to essential climate variables, which are probably better known, or essential biodiversity variables. Just to give you an idea, we just want to improve the information and to do better monitoring for certain policies. Typical information is rangeland mapping, cropland mapping, crop type mapping, field boundaries, condition assessment, crop yield. And so rangeland mapping can be used for livestock production, but also state and change of land use for livestock production, cropland mapping, food production, etc., etc. So what we try to do here is the EO application linking it to an EO, to a policy, application. And that's the whole idea behind the EAVs. A quick example to make it a bit more concrete before I go into the more theoretical analysis of an EAV. This is the WorldCereal crop type map. That's an ESA project that started a long time ago. It's now on its second run for another 2 years now. I think they finished their first year of the second implementation. And so the idea was to see how far we can get with commonly available open data on crop type mapping at global scale. They needed to have seasonally updated crop type maps at global scale based on Sentinel-1, Sentinel-2, Landsat, what was available. So there was a number of research questions like, how do we define crop calendars at global scale? When do we trigger the system to update? So they need to divide the world into different agroecological zones, and then come up with definitions for cropland, come up with definitions for certain crops. You see winter cereals, spring cereals, maize. There was even also a part on irrigation. And then if you zoom in, for instance, this is what you have. So temporary crops is actually agricultural land. Then you have winter cereals, maize, active cropland to see, okay, in this season, which was active, which was not active. Of course, this is not the only product like that. There's different products like this. And there was an interesting study by also a GeoGLAM collaborator, Hannah Kerner, to comparing all these existing land cover maps, both in this case for sub-Saharan Africa. Of course, you know that there's going to be a mismatch, and you could see this as some kind of competition. You could see like, okay, which map is the best, which is not. But this research was not done for that reason. This research was done for collaboration, because you see areas where all the maps actually perform very well, and you see areas where all the maps are actually quite wrong. And this is how we work within GeoGLAM. So this kind of analysis really guides us towards areas where we need more research. Is it just because of lack of data? Is it in-situ data? Is it EO data that there's a lack of? There's some parts in the world that are still not very well covered with all the open data. Do we need more higher resolution data? Do we need different data sets? And so what we try to do within GeoGLAM in the research community is come up with best practices and standard documentation on how to map, or how to do yield estimation, or how to do whatever important parts. So that's really the research component of GeoGLAM. The EAVs is not something that we recently started. It started in 2019. We have over 40 variables defined. They link with the essential climate variables. So if there's, for instance, rainfall, if it's used within ECVs, we don't change the definition. What is essential? So they're key building blocks. They need to be focused on agriculture. Variables, they need to be measured or inferred from and change over space and time. And for GeoGLAM, yeah, for us it's EO based and meeting our policy mandates. So actually what they're a translation between policy and use and data. So in that way, it's also very much linked to the space agencies. When they have new satellites going up, we can check the data which meets which policy and the other way around. This is a definition or a graph of what we have now as essential agricultural variables. On the left side, you see the mapping part. They're binary spatial. So you have the agricultural mask that consists of cropland mask, agroforestry mask, rangeland mask that falls into temporary cropland, pasture, perennials, etc., etc. You have categorical variables, which are spatial. You have continuous variables, and they're split into spatial and non-spatial. All the information can be found on this website, agvariables.org. This website needs an update pretty soon, but we're actually working on that. In May, we have a big meeting on the essential agricultural variables. And I guess after that meeting, we will be updating this site as well. Just to give you an example, this one is for crop condition. So you have a definition, you have the frequency of update, you have the spatial unit, you have the policies, and you have all the related variables. And you have like EAV stewards, so people within the GeoGLAM domain and a bit outside, who are actually experts on that domain, and we're working on getting the definitions right, getting the related variable right, getting the frequency update right, and also there's an ongoing discussion on what level of accuracy that we do need for that. One of the things that we did, for instance, is for those essential agricultural variables, what kind of open data is available. That's an exercise that we did in 2019. So we really need to update this table with all the new data coming up. And that's one of the things that we will be doing in ISPRA this year from 13 to 16 of May. And yeah, everybody is welcome to join and input. In-situ data coordination. I mentioned WorldCereal, the ESA project. They did a big job of collecting crop type data at global scale, harmonizing it, managing it, providing metadata, and providing quality in it. And that's the basis of our database of in-situ data. Of course, there are areas in the world where some of the in-situ data is still lacking. And so this is really something that we really want to do, is reach out to the research community, people working in Asia, in Africa, in Latin America, to share their data so that we can expand and actually do calibration and validation of some of the global products, but also push research further. One of the other things that we have is, as we know, in-situ data is very, very expensive. And lots of projects struggle with getting in-situ data. So if you know where people are collecting data, you can already reach out to the other people and say, okay, we don't have the budget for the full country. You guys can do a part, we can do a part, can we share our data and continue work? An example here was, for instance, Malawi. For this year alone, there's 4 or 5 different GeoGLAM partners working in Malawi in different regions, different budgets. And so, yeah, now they can share and do the work together. Then, of course, next to the in-situ data, there's also something what we call JCAM. JCAM is the Joint Experiment for Crop and Assessment Monitoring. It's a global network of voluntary research sites that actually do research studies, implementation of different methodologies, looking at different EO data, looking at different algorithms based on EO data, and actually share, inter-share the data and inter-share the experiments. A big experiment was the SAR intercomparison, where all these sites got extra support from Canadian Space Agency, where they had their new SAR data. So for the Canadian Space Agency, they could test their data over different agroecological zones, see what the impact was, and all those sites had extra data where they could use different SAR data on. So that was published. So it's a big publishing network. It's also on a voluntary basis. So people with research sites can actually fairly easy join the community, set up experiments, share data, and get in contact with a global network to do publications. Yeah, this is explaining a bit what the assets are. Again, just an example of a region where some of the sites are well, we could do in Southeast Asia with a bit more sites to cover that area as well. Then, of course, so that was operational to research. All that research, all that operations that goes into capacity building and co-design, the GEOGLAM community has developed a document on a guidance document on good practices for designing, implementing, and evaluation capacity development. So actually, the idea there is that whatever project is implemented by GEOGLAM or one of its partners should follow these guidelines on capacity building and co-design. Couple of examples of that capacity building and co-design. Last year in March, so a year ago, we did a big Naivasha workshop. We still call it the East Africa workshop, but yeah, it goes down, well, it goes from Uganda to Lesotho in Southern Africa. So yeah, let's still call it East Africa. And actually it was to bring together experts from these different countries so that they can exchange and understand what the gaps were on implementing crop monitoring, what were the successes, what were the failures, why does something work, why something doesn't work. We brought together a number of GEOGLAM experts to support all these countries, and the outcome was actually a gaps and needs analysis for all these countries, but also draft documents with which those countries could go to donor communities and ask them, okay, we want to implement this, these are our needs, can you support us? Other examples from the GEOGLAM community is CropWatch. CropWatch is a program run by our Chinese colleagues from RADI. They do quite a lot of capacity building within Africa. They run their CropWatch platform at national level. In this case, it was a training in Mozambique to set up the CropWatch system. That system could then support the crop monitor system at global scale. Another example here is with DAPSA. DAPSA is the statistical department in Senegal, where another program, Sen4Stat, which is a European Space Agency program, actually supports in improving the agricultural statistics at national level. So underlying, you have, of course, crop type mapping, but also sampling schemes, how to extract sampling schemes, how to improve sampling scheme, and then ultimately lowering the uncertainty of your statistical estimate on crop production or area estimates. This is also done in collaboration with the FAO, with EOStat. And then another example here is developing an agrometeorological bulletin in Angola, where some of the techniques that are used in crop monitoring, in general agricultural monitoring, are then implemented with the agromet services of a country to come up with these kind of bulletins. Another example from our Chinese colleagues, where CropWatch actually installed the regional center in Abuja in Nigeria. That actually does a regional approach for Western Africa. Crop type mapping. Sentinel-2 for agriculture is another software project, software tool that was developed by the European Space Agency. It's one of the precursors of the Senverstat tool. So this was a training in Mali, actually, on the use of that tool. It's now being implemented in the region. Moving away from crop type mapping, and there's also part on drought monitoring, again, an ESA project dedicated towards South Africa now, or Southern Africa, where we work with national met agencies to improve drought monitoring. So looking at the effects on crops and crop types, on the effect of drought monitoring and early warning drought monitoring. All this data is then captured and stored in the Geo Knowledge Hub. I should have started by saying that the GEOGLAM is actually a flagship program of GEO. GEO is the group of Earth observation. The Geo Knowledge Hub is a big part of GEO, where actually we use it as storage of all the information that is gathered within GEOGLAM. So we did several webinars on the different tools, the Crop Monitor, ASAP, which is GRC tool, GLAM is the agricultural monitoring part of NASA, CropWatch, I already mentioned, is the Chinese component. We did a webinar on co-design, co-development. We even did a webinar on proposal development. All that is stored within Geo Knowledge Hub, so those webinars can be seen. The software is also stored there. There's some data there. There's exercises there, so people can really work with it. I don't know how I'm doing for time. Okay, so a couple of more minutes. I'm gonna quickly run through some of the examples. So what I tried to do until now is a general overview of all the different components of GEOGLAM. Now, quickly, some applications. A big one, of course, is the Copernicus. Is crop type mapping. So Copernicus for GEOGLAM is an EU-supported program that actually supports GEOGLAM in providing crop type maps in the global south. Previous part of the program that ended last year, they did mapping in Kenya, Tanzania, Uganda, and Yemen. The next one that's going to start is in Mozambique. So actually, in collaboration with the people from the Joint Research Center at ISPRA, we discussed, okay, which countries have a clear demand for crop type mapping? Where can we support? What is the biggest impact? So, and then a consortium that is selected by the GRC runs the crop type mapping in the country. Another example is crop type map for Zambia, Mozambique, and Zimbabwe. And this is done by our Chinese colleagues, where they use crowdsourcing data, but also other information to come up with cropland maps at a higher resolution data. And they run it so that the countries can actually do it themselves. Also get an idea on how they should collect some of those crowdsourced information, and then use the cropland information in further analysis of their agricultural needs. Of course, impact is also done. again, an example of crop watch where we just didn't, our Chinese colleagues analyzed the impact of cyclone, how much agricultural area was flooded, and what would be the impact on food security. Malawi, also a cyclone Freddy impact. So there's, as I said, there's more than 100 organizations that are part of GEOGLAM. Different funding agencies, different countries they focus on. So our Chinese colleagues worked in Mozambique, and NASA Harvest worked in Malawi to see what the impact was of Cyclone Freddy. And of course, these reports go to the Ministry of Agriculture, but also to UN agencies that can start support in those countries. An old one, COVID rapid response for food security. What was the impact of COVID when people couldn't go to the field? What was being harvested, what not? What was the probability of crop and crop failure? So that was an analysis also done for Togo from our colleagues, NASA Harvest, using some of the planet data, so the high resolution data, actually supported the government of Togo to come up with a program to support smallholder farmers during COVID. Another typical one, Kenya flood mapping. What was the impact of the floods? How much agriculture was affected? And what would be the long-term effect on food security? Pest and disease, the armyworm, what is the impact? How can we detect it? How can we start to try to stop the spread? What early warning is possible there? And this is still in research, of course. Is the detection that we do early enough, etc., etc. This is again yield estimation for Malawi, where we looked at, okay, how soon can we actually start predicting problems in yield, and actually warn the Ministry of Agriculture of an important shortage so that they can act early. And this was also driven by the El Nino effect, which really last year had a serious effect in southern Africa. CropWatch, again, an application of CropWatch here, which, okay, I'm almost there, sorry. For Zimbabwe, where they actually set up a full system so that the Ministry of Agriculture could actually look at what was the agricultural production, agricultural areas, also irrigation. And then in Benin, again, an implementation of different GEOGLAM partners on agricultural information services, where they used very high resolution data to come up with some of, well, to also cover some of the smallholder farmers. On the slides, you will always see the GEOGLAM partners and with whom they collaborated. Kenya, crop monitoring in Kenya, in close relationship with the Ministry of Agriculture, and we wanted to see what potential there was for more detailed crop condition reporting, pest and disease outbreaks. But that was scaling already some of the fall armyworm predictions. And then before we go into the questions, some concluding thoughts. It's clear that the challenges for food security will increase. You have all the climate extremes, you have pest and disease conflicts, and the work we did in Ukraine over the past couple of years really shows that how important EO data is for in conflict. So yeah, EO will play an ever-increasing role to inform policies, but also programs, and to inform global institutes to keep an eye on global food security. I think what we really need to do is, and what we see now with the changing geopolitics, is sustained solution and long-term continuity. If you look at the impact of different projects, different programs that are all of a sudden ending because they only had one big donor, and the donor community stopped. So we need to find a solution for that, more donors, more sustainable solutions. So everybody's thinking about those. We also need to scale up co-development. We've seen more often that it's externals coming into a country, explaining things or running things, and then when the funding ends, all the effort ends. And then, of course, there needs to be a better integration across different sectors and domains. There's lots of linkages with the water domain, with the forestry domain. So we need to get out of our silos. And I think that leaves us just enough time for a couple of questions. Thank you very much.
Perfect. Thank you very much for a very, very interesting talk. And it's very important, the link between results and actionable insights. So how the GEOGLAM results actually help governments to take measures to rectify some of the problems. And I would like to open the floor to questions. We have time for a couple of questions. So any questions from the audience? I can begin by asking one myself. I've seen the last slides that you're expanding your work in pest and disease foresight or detection, and then providing actionable insights for that. I was wondering about the coverage of this work. Is it mostly for the armyworm now, or are you expanding this aspect?
Very good question. So this is still very much into research. There's a number of research applications there. So the one I showed was fall armyworm. There's a couple of others. There's already a big work done by FAO and some other colleagues on desert locust, impact of desert locust. So that's definitely one. So GEOGLAM, we want stuff we want to see how much scaling is possible. That's really crucial for us. Of course, not all diseases, not all methodologies are scalable. So then we need a regional approach or even a national approach. Wheat rust is a big one in Ethiopia, for instance. So there's a number of projects that work on detecting wheat rust and the spreading of wheat rust. So we're looking at the most important diseases, but with the pest and disease, it always starts at very local, national level, and then we see what is what is scalable. For that, for instance, the JCAM network is really, really crucial, so that you can actually see, okay, this is a methodology we run for disease X. Does that work in your region as well? Of course, not all diseases happen in different regions, so there's a spread. So with the pest and disease, we really look at local, national, and then see how scalable that is. Of course, desert locust, I'm not going to say it's an easy one, but there's a big region that is impacted, so the regional approach is there very well straightforward, or more logical, let's put it like that.
Perfect, thanks. Any questions from the audience? Please raise your hand or activate your microphone. We have time for a really short question because we have the next event starting in a couple of minutes. So I'm trying to see here if we have any interest for questions. Well, I can ask another one myself because there's quite a bit of things that came up to my mind while I was watching. I noticed that you have data for some countries on your maps, but not for others. Is that a matter of where the crops are grown, or is it a matter of who participates and support GeoGLAM?
In which maps?
The wheat map, for instance. If you look at the wheat map, for instance, and this, while I was checking GeoGLAM earlier today, I see, for instance, for Jordan, there is nothing on wheat. And I didn't know, is it because, you know, it's a matter of participation? Is it something else?
No. For those maps, I'm not sure which maps you're referring. If you're looking at the WorldCereal, for instance, it might be that at the moment you're looking at the map, because it's not one map, it's seasonally updated. Okay. It might be that there was no growing season in Jordan at that time. So in principle, and also in the crop monitor, in principle, the large growing areas should be displayed depending on the crop calendar. So you have to really take into account that it's a dynamic map that changes with every month, let's say. On the in-situ data, that's really data sharing. So that depends on organizations, on countries, on data sharing principles. Of course, we want to have everything open and free, but even if you look at Europe, which is definitely, if you look at global scale, the area where most data is shared, even within European member countries, there's a difference in how data is shared. Some countries have their data of the LPIS open and free, and you can download it from a website. Other ones you need to apply and ask for them. Other ones only make it available 2 years after the data has been, well, the season. So it really depends. So on in-situ data, it's depending on contacts and members. On the EO data, on the crop maps, it should, and I'm not saying they're 100% correct, but it should cover all areas. Okay,
perfect. Thank you very much for this very, very interesting talk. I apologize for the shortness of time. And we'll get in touch because this work is very interesting for the center, and we're very active with some EU Horizon projects that are very similar in scope to the work you are doing, aspects of them. So I think there is room for a lot of interaction, collaboration. So thank you very much for your time, and we'll speak again soon.
Yeah, thanks a lot, and thanks for the invite, and always a pleasure to present GeoGLAM.
Great, thank you very much. Bye-bye.
Thank you. Bye-bye.